Are you ready?
Can everyone hear me? Okay, so I'm going to try and go really fast. I don't have it up yet, but that's what the URL will be if you want to look at this later. So let's say you have an in-app messaging system. And so you've got obviously the users, the message, you've got message tags. Like let's say a really simple one, you've got if they've read it, then it tags the message as read. If it's deleted, it tags it as deleted. Or if you sent the message, it might have a critical tag. And then you would have like a table for tags saying like what icons, if any, or what have you, what sort of tag it is. Like if it was sent as a tag for the message, that would be like a priority tag versus a status tag like deleted. So let's say you do a really simple join here. You're thinking this is going to be nice and easy. And I'm going to go fast. These are all the little joins. And you just limit it to 15 messages. And if you see here, right now we still have, all the deleted messages, and we still have messages that have tags from other users. This is just, you tried to do it simple, and then you realized, wait a minute, you're going to do an inbox, and you don't want deleted messages in the inbox. So you add this where clause, and you realize, oh crap, I should have done a subselect somewhere. Because you end up with missing data. For example, this message 12,000, I don't know if you can see it, but it was deleted by the person who sent it. So it was just, it was deleted from their sent box. It's a tag with that message ID. It was joined on the message, but that was the only tag on the message. So when you said like, where not, deleted, it just totally got rid of that message. So you got missing data, and then you have unwanted data, because basically you joined all the tags on, and you've got, that I said I had, deleted it, and I read it, and maybe it was a critical priority. And when I did the where clause, I just took the row off for it being deleted, and I just left it as if it was not deleted, and that'll make your users really unhappy if they can't delete things out of their inbox. So here we have a subselect crime scene. So basically to get the null values and to get the messages that don't have tags, the null issues, and then also to get all of the, and it's a huge mess. You're trying to select everything that's not deleted or that's not in this subselect of deleted items, and then you join on the ones that are null, and you do this union, and it's just a crime scene of subselects. It's like huge, huge mess. I didn't actually have time to redo the whole thing with lateral join, so I'm just showing you one line of it redone, and I wanted to show you. So let me see if I can get them both on the screen at the same time. Let's see. So let's go up. Well, I guess we can't get the whole thing on it. So you can see this rather messy one up here where you're left joining message tags, based on the message ID and the tag name, and not in this selected area, and it's long and messy. And I wanted to show you with a lateral join how you could do it, because in the other version you sort of have to keep taking the same information and rejoining it, because you're trying to make sure you didn't get rid of things for null values, and you're trying to, a lateral join does it at the same time. So you have everything you've joined so far, and then you're joining based on two separate tables. I mean, it's really just a quicker way to do subselects. So, and I wanted to show, like with this, you do join lateral, and then you have the select in there, just like a normal select statement. You do your casting in there instead of up top, where you say like select, M, and you would cast at the top. You do the casting right in here, and you just give it like this little name at the end. I just called it MT1, and it's already cast. And then I wanted to show you it's just no, you can put subselects in your lateral join if you want. You always, of course, are joining based on true. And I have 10 seconds to go. We did this in production, and it sped up from 230 milliseconds to about 30 seconds.
Right on.
Yeah, so, woo! Okay. Yay. Okay.
I'm here to talk about, I'm Brandon Rhodes, and I'm here to talk about SSH, the encrypted protocol that lets you speak to other servers on the internet without other randos in the coffee shop convincing your computer that they are really the server or hearing everything that you say to and from your server when you're connecting to it. Typically, you use SSH to get a command line from another computer where you can run commands just like you can on your own if you're running a decent operating system. Well, I mean, even in Windows, you can get a command line up, but it's a sad thing. And SSH lets you get a command line remotely that can do all the same things that your local one can. And it uses math to make sure it's really talking to the server it thinks it is. Python has a native library called Paranemico that lets you speak that SSH protocol when talking to another server out on Amazon or somewhere else. And I wanted to just mention a few things that I've learned over the years trying to use it that also teach a few things about the SSH protocol. Typically, when I would first try using it, the result was rather sad. I would write a little program, I would cut and paste from Stack Overflow or a networking book or something, and I would load up my host keys so that I could tell one host from another and know if they were trying to fool me. Connect, here I just connect to localhost, invoke a shell, and then try to write a command, like do a word count on a path. And nothing would ever happen. Nothing would ever come back. And it was a long process, since nothing displays and the program hangs forever, to learn that the problem is that after the command had run, the shell prompt had come back, patiently waiting for me to send another command, and so the .read I'd run that was waiting for the socket to close and the end of file to get signaled was never returning. And so it was this standoff that just lasted forever between my little program that's going to wait forever and the shell on the other end that is also quite prepared to wait forever. So what you learn is that you either have to put your command ;exit so the shell at the other end hangs up when you're done, or you can just tell it to exec to replace itself with a command you want to run, and so you get this back. Because the shell thinks it's just talking to a person. It welcomes you to the machine, tells you what version it is, when you last logged in, and the actual line of output that I want from the word count command is stuck down there at the bottom. If I know it's one line, that's great, but what if you're catting a file or checking what users are logged in, and it could be multiple lines? You wind up with just a mess where you do a compound command. You first echo some big obvious line that will let you tell the junk at the beginning of the session from the end, then run your command, and you now at least have a minimal working routine that will go, you can split and separate the gobbledygook from the output you want. So here are 5 things that will make that situation better. First, yes, SSH can start a shell session for you. You never want to do that. If you want to run several commands, you'll never know where one starts and the other stops. Use exec command as many times as you want. Each time you get a separate input, output, and error file that you can read and write from that is completely separate from that of the next command you run, so you'll never confuse standard out and error. You'll never confuse the output of one command with another. You will not be welcomed with a banner message when you log in. Second, remember to quote your arguments. These are shell commands, so run pipes.quote on every file name and argument you pass, because otherwise your script will work fine until the day that a file has a space in it. Using the input, output, and error, I mean, you can do very fancy things where you write to the command on the input and read some output, and that's very complicated. Here I just show how to use that error output object to check the status and see what came back from the error stream. Very important when learning about running other commands locally or remotely. That output, which is data, and error, which is all those little can't open this file messages, are kept separate at the OS level so that you never confuse one of the messages for the content of the file. 4, you can create an FTP channel and manipulate files directly like you're a file modal or like a little file system app. And then finally, you can run as many channels as you want. SSH keeps them all magically separate. I'm Brandon Rhodes. Thank you very much.
Yeah.
Okay, how many people here have heard of Bloom filters before and know what they do? Oh, well, most of you. Well, okay, you guys can take a nap. For those of you who don't know, Bloom filters are a pretty remarkable data structure, and more people should use them and know about them. They are data structure for checking for presence within a set of data. Okay, so they, if you need to say, let's say you have a system set up where you have a really slow back end that has some data, and you want to, before you actually go to that very slow storage, very slow I/O or whatever, you want to say, hey, do you have this data? And if they say no, then you don't even have to go visit it. That's what Bloom filters are really useful for. Inserts into Bloom filters are constant time. Lookups are constant time. They are extremely space efficient. So they seem like this absolutely magical data structure, but there are some downsides to them. The main one is that they don't actually contain the data. They're just checking for presence of the data. Is this piece of data in the data set? And you can't really do deletes with Bloom filters. There are some variations that are a little less space efficient that will let you delete, but for the most part, you can't actually delete stuff from them. So if you have to, then you have to rebuild the whole thing. But usually it's not too bad because you're using them in front of a slower data store. They're also a probabilistic data structure, which means that you can get false positives. So if you say, does this contain this piece of data? If it says no, then you absolutely know that it doesn't contain the data. But if it says yes, that really just means maybe. And you actually have to go to the backing store and check to see if it's there or not. So that's why they're filters, right? They will let some things through to the very slow back end, but you'll never get a false negative. So the way it works basically is you have, when you construct them, you have 2 knobs. You say how many hash functions you want and how many hash buckets. And when you give it a piece of data, you hash it using each of these hash functions. And then you sort of take a modulus for the number of buckets. Each bucket, unlike a regular hash table where each bucket might be a set of things, in a Bloom filter, a hash bucket is 1 bit. That's why it's so space efficient. You can have 8 million buckets in 1 megabyte of space. So that's pretty remarkable. To add stuff to a Bloom filter, you just set that bit in the bucket for each of its hash functions to true. And to look it up, you do the same thing. If all the bits are 1, then it returns true. So it might be there. So I'm going to run through a quick example. Up here we have basically 10 buckets. All right, and right now the default state is they're all false. We're going to add this value foo to it. We have 3 hash functions. And so, we get 4, 6, and 2. So at the bottom, you can see that we have, the bit 2, bit 4, bit 6 are all switched on. Okay, so we're going to look at bar. Okay, so that's we're carrying over from before. We look up bar, and the values for that are 2, 5, and 3. We look at each bucket. So bucket 2 is true, but buckets 5 and 3 are false, so we return false. We know that it's not in the set. Now we're going to add baz, same basic idea as before. 1, 3, and 5 are its hash values, so we set the bucket values to those to true. And then we're going to look up bar again. This time, 2, 5, and it's the same values as before, 2, 5, and 3. But it now returns true because each of those bits for buckets 2, 5, and 3 are all true. So even though bar isn't actually in the data set, a lookup says that it's true. That's a false positive. And so you would need to, go hit your really slow database backend or whatever and actually see that it's really not there. But you can save so much time by filtering out things that are not going to be there. And that's really, really useful. I just kind of I just whipped up these slides about 20 minutes ago, so I haven't actually implemented it in Python. But there are Python implementations of Bloom filters, one by Jay Baird called PyBloom in Pippi, and there's a really good, if you want to implement one yourself, and you should, there's a good tutorial at that bottom URL there that kind of actually goes through the steps of, creating the buckets with the bit fields and setting them and all that sort of stuff. And if you like this sort of thing, there's lots of other kind of probabilistic data structures that are neat. Another one that's sort of similar to Bloom filters is called cuckoo filters. That uses cuckoo hashing, which is like this whole thing, but it actually will allow for deletes, and it's roughly about the same efficiency in terms of lookup, insert, and space efficiency. So it's pretty neat. So that's it.
All
Thanks
right.
a lot.
My name is Zach Wick. Officially, my talk is about Emacs major modes, but it's really kill two birds with one stone, because I'm also going to talk about this program called Scent. So in this little shell that no one can read. All right, we're getting to the Emacs major modes. We're not talking about fonts or XR&R or anything else. So Scent is a program that reads files that look like that bottom right buffer there. Oh, you know what? I pulled up this other buffer specifically so I could make this larger.
This is what happens with Emacs.
No, little baby computer, yeah. So how small the fonts must be on that little screen. I know, it's amazing I get anything done. So,
all right,
you can read the bottom right now. Woo. Sweet. So, Scent allows you to write presentations in this format, and lines that don't begin with white space or lines that don't begin with white space. I have killed my X server, apparently. So lines that don't begin with white space show up as the whole line gets as big as possible and fills up your entire window. And lines that begin with white space or pound signs are comments and do not make slides. You can include images, PNG images, and notably, there are only 3 dependencies for Scent because it's like 1,000 lines of C. You need xlib, libpng, and farbfeld. So this is all well and good, but in making my talk that I just gave previously about Python 2 to Python 3 transitions, it's really hard to read speaker notes like on the fly if everything is white like this. So of course, you can do whatever you want in Emacs. And there's this super cool tool, which is this bottom left pane here, called Generic X. And Generic X is a Emacs major mode that, in addition to giving you syntax highlighting for batch files, INI files, Apache Samba configs, like all of these things out of the box, you can use it to make your own Emacs major modes. And so there are some lines down here where you can see that, oh my gosh. So we'll do this. So you can see here that I say, all right, my comments start with a pound sign. Some keywords start with an @ that's how you include an image. I don't have, that first nil is I don't have any other special commands in my little DSL for making Scent presentations. And then at the end, I want to be able to do like a require Scent mode. So that's what that line 13 there is. And that means that in my Emacs config, I can do something like this. And if I ever load a file that ends in dot or has an extension of .scent, it automatically loads and applies my Scent mode major mode. And so I can go from this to this. And this is much easier to read on the fly, at least for me, if I'm like talking and have to glance down at my notes. The cool thing you can do with this is any configuration file or DSL that you ever have to deal with in Emacs, you can colorize it however you want. During the interim between my talk and these lightning talks, I tried to make a PyPI mode. I could not get it to work because my Emacs Lisp skills are very rusty, and I'm not super familiar with PyPI. But I have used this to make major modes in Emacs for other little DSLs for making little configuration things and things like this. So if you use the correct text editor and operating system, you can do this. Oh no, a caveat here in my last 30 seconds. I'm fairly certain that generic X is only in Emacs 24 and newer. And if you're using OS X's crippled version Emacs 24, you have to do something else special, and I have no idea what it is. But I know that you have to do something special. Thank you.
Yeah. Are you Sam? Yeah.
Okay, great. So, hi, I'm Sam. That's my Twitter handle. If you have opinions on this and want to yell at me afterwards. And I'm going to tell you that you are not Facebook, and that is OK. This is production engineering for the rest of us. So I work at Twilio. We're sort of big, but we still are not Facebook. And I'm going to talk about how we think about building services to satisfy our needs rather than having a billion users. I'm going to open with a quote. 99% of websites are not the top 1% of websites. This is important for us to remember. And I'm also going to open with an architecture diagram. This is Uber's new data storage architecture. I just read this on their blog. It's called schemaless. It looks really complicated. It was a fascinating read. But I'm pretty sure that internally, inside the company, it looks like this.
Yeah.
They probably have a team of a dozen engineers whose full-time job is to support schemaless. We don't. You probably don't either. So here's how you should build things. What should you think about when you're picking technologies rather than what you're going to do if someday in the future you're lucky enough to have a billion users? So first, let's talk about picking technology. There are open source projects for databases, web frameworks, metric systems, JavaScript, implementations for just about everything you're going to need. You should use them instead of rolling your own. Most of the time, older tools are better. They've stood up to the test of time, and every scar that they have from battle damage is something that somebody else learned, so you don't have to learn it again. On the flip side, you should also look at the current maintainership. Look at the commit history on the project. Is it being actively maintained by people who aren't the company that originally wrote it? The gold standard here is really the big name Apache Foundation projects. So, well, Apache the web server itself, Hadoop, Kafka, Lucene, ActiveMQ, anything that's super active, maintained by the community rather than, like I said, the company that wrote it. You should also look to see if there are consulting companies. When your Postgres instance dies at 1 a.m. and you can't restore it from the backup because something screwed up, you're probably going to want help. And having somebody on call to do that for you is going to be really useful. And finally, you should look for landmines in the licensing terms. If you're writing mobile apps, there's one caveat. The GPL is incompatible with the terms of the App Store. So unless you can find that library under a different license, probably shouldn't use it. Next up, let's talk about infrastructure as a service. There are companies out there that build hosted solutions for everything. To rattle off a few, and these aren't endorsements, Datadog or Staticify for metrics and collection monitoring, Rollbar, Bugsnag for capturing your errors and logs from pretty much anywhere, Travis and Circle CI for testing, and obviously GitHub or GitLab for if you want to use source control. Everything you can pay somebody else to do is a problem you do not have to solve, build, or maintain yourself. And finally, a few more thoughts. Your customers are likely to be more forgiving than you think. Outages are survivable. They'll be even more forgiving if you haven't promised them 5 nines. So under-promise and over-deliver. 5 nines, if you don't know the math here, that's 5.5 minutes of downtime an entire year. That's really hard. I work at Twilio. We have 200 engineers. We don't hit 5 nines. And please think about disaster recovery before you have a disaster. The biggest question to answer is how large of a failure do you want to tolerate? If you're running on Amazon, do you want to tolerate an AZ failure? You probably should. A region failure, that's debatable. And test that plan before you have to do it under fire. You'll thank me later. That's all I've got. Happy building.
Yeah, woo!
Okay, success. Okay, so I want to know something really crazy before I start this. This was a lightning talk at PyCon 2016, and then I built it out to a full talk here, and now it's a lightning talk again. So I've come full circle. All right, so this is Python and Raspberry Pi in the library, the fundraising edition, okay? So for those of you who saw it earlier, it's slightly different. And I just want to start out by saying thanks to Matt Wilson and thanks to IndiePi, who have already gave us $200 so far. So thanks to them. All right. So what this is, my name is Q-Misha Goss. I go by Q. I'm a librarian for the Detroit Public Library. or my favorite one of these is Computer Lady, as the kids like to call me. Detroit Public Library has 21 branches and 1 main library and a mobile bus, bookmobile, whatever you want to call it. All of our programs are free, and all the sign-up is voluntary, and everything has to be easily accessible because it's free to anybody who walks in on the street. So the library experience, this got cut down to just this. Right? So everything is not online. Google has not replaced us. Library still exists. We are more than books. And what I'm going to tell you about is our more than books thing. I run this program that's called Parkman Coders. So I'm going to tell you about library programming. And if you would like to do library programming, you can too. You don't have to be a librarian. So the diversity shortcut, I thought this was important, so I'm sharing it with you again. Libraries already have a diverse population. You do not have to like browbeat people and figure out how can I get girls to do this? How can I get people of color to do this? Go to your library where the people already are and bring it to them, okay? It'll be much easier, okay? So these are some of my kids who just finished RoboPie. We made paper robots with LEDs. We just finished this on Thursday. Okay, so I'm going to tell you about Parkman Coders. This is my display that I put up in the library to entice children. It's better than candy in a van. Safe, right? So just put the box up, right? Parkman Coders is meant to introduce our young patrons to Python and computational thinking. All of our kids like to play on the computer all day. They have a library card. They can get on the computer for 2 hours a day. And they use every last minute of that 2 hours. And then they come and say, can I have more time on the computer? And then I say, no. And they say, it's boring here. There's nothing else to do. Let me get back on the computer. And I say, read a book. And they go, no. And then I say, read a book. And they say, if I can get back on the computer. And then I acquiesce. So this is to get them to stop playing so many video games, maybe learn to make something of their own, be creators instead of constant consumers. So my program focuses on kids who are between the ages of 7 and 15 because that's who comes to my library. It's a bad age group because they're too widespread. Little kids don't pay attention. Some of the older kids say, I already know this. We use Raspberry Pi mini computers. Right now we have 10. The point of this fundraising speech is to get more money because we usually get about 30 kids that are interested in participating, and right now they all share. So that does not work out too bad. Yeah, so we teach them the basics. We let them use it in Minecraft Pi. Right now, my older kids are building robot cars. We're going to do that next week when I get back. We're going to finish robot cars. And really, I would just like to continue to promote computer science so I can make productive little people at my library who will read books on their own one day. So these are some of my little people who have finished programs previously. And I see these kids all the time. Some of them are regulars. They basically live at the library. They're there before I get there to work. And they ask me all day, Ms. Q, can I have more computer time? When are you going to do another program? When are we going to get to build something again? So that's them. So for this fundraising, things that we can use, more Raspberry Pis would be nice. I would like to get 20 more Sense hats so we can do a little bit more building out. Pepperoni Explorer hats, I have a couple of those now. That's how we're doing robot cars. More of those would be cool. So would cameras. If anybody's in Detroit and would like to volunteer their time, that would be awesome as well. And this is the site that I set up, GoFundMe.com, Python in the library. I would appreciate your help, and thanks for having me out here and listening to me twice in one day. Thanks.
Probably seen the shirts around. I think statistically 1 out of 3 of you have them. We're based out of Charlottesville, Virginia, and I'm here to talk about extending the principles of open source into science at large. So first of all, we have to kind of like define what open source is. Whoops. You know, the mouse just moves around. And hopefully we can start with the assumption that, like, generally speaking, open source is better than closed source, at least for, you know, like scientific research at large. Oops. Oh well, we'll just start here. The GNU.org or GNU.org defines like 4 freedoms of free software that basically encompass what open source means. I think it's like a good place to start off in terms of what, like if we're going to take open source, we have to kind of like find a way to transport it into other fields. So we need a formal definition. Wow, I was just so not ready for this. You know how like sometimes the screens line up and then sometimes they don't, and you have to like move the things around? Never mind. So the program can be run for any purpose in any way that the user wishes. The OSF itself is on GitHub, and so it's under an Apache 2.0 license, which is sort of already the case. So our source code follows this principle. In addition, we really push for everything on our website to also be used in any way it wants to. And luckily with scientific papers, we already have this kind of being the case. Like you can cite, basically, I mean, don't quote me on this, but I'm pretty sure you can cite anything under any circumstance as long as you're like, you know, attributing the right information to it. So we're good to go there. Sometimes it's not always the case. This is an EULA from a fruit-based MP3 player that I will refuse to name. You can't produce any nuclear weapons with it. And that's good, probably. But on the flip side, like you can't use it for life support machines. So if someone devised a great way to use this fruit-based machinery to you know, save someone's life, they couldn't do it. And like, while it's a ridiculous example, it can be generalized to like, you know, less extensive ones, less insane ones. Already mentioned that. The other thing is that the users can see and modify the internal workings of the program. Again, OSF is on GitHub, Open Science Framework, but we also wanted like more than just our information. We wanted the information that people are putting onto our website to also have this be true. So we've invented these like badges, this open data and open materials badge, and it basically gives you more validity to your paper and your information for like putting this, or for putting the data and materials up alongside your paper. Copies can be distributed freely. Again, we're on GitHub. But more so than that, we have a big make public button right here for any project that you make, and all you have to do is click it, and it links to our API, or it becomes public on our API. You can access it for free. And the changes can be distributed freely. So that means you can take what's already there and improve upon it. And that's something that like science really hasn't been good at, with like reproducibility for one, but also say like you want to like reference a paper, but it's behind a paywall, so you can't see it in the first place, and you end up conducting the exact same experiment. Well, we have this great little forks button that does exactly what you think it does. We're trying to introduce these ideas of open source, such as forking repos, forking ideas, and building on the shoulders of giants. This is just more information on that. You can just click have a new fork, and it copies everything that person did without changing what they did. And so you can add on to that, you can change it, whatever you'd like. More than anything else, we kind of wanted to expose like the scientific community at large to these ideas of like open source and open source principles, and really make it clear that like this isn't just relevant to computer science. It's relevant to all the sciences. And the rate of change of computer science is like in large part due to having these open source tools available. And imagine like what we could do if we had those same principles in the science, or in the sciences at large. That's all I got.
All right.
Sweet. All right, so yesterday I came to the lightning talks and I talked about this idea of let's make a new model for teaching people to sprint. I wanted to give a little feedback on how that went last night and then talk about a couple of the random things. So we had, I think, about 16 some odd folks come to the mentoring session. We walked through virtual environments. Everyone set one up. We got hands-on practice at that. Everyone walked through exploring Git, and they pretty much all of them were able to put one or more commits up onto the project. I got a lot of good feedback. Very nice thing, the folks from Pi Ohio donated to me several books that if you come back tonight for this evening sprint and you continue to help me working on this thing, anybody who successfully gets a commit into the project will be entered in a random drawing for one of 2 Introduction to Python books. I'll totally help anybody out figuring out how to use Git, etc. So the project seems like it's headed on its way toward success. I'm hoping folks can help us out again tonight. So that's the first random stuff thing. And the second random stuff thing is a little different. My company, Booz Allen Hamilton, we had a booth out here, and we've run a competition throughout the course of the past 2 days. We had about, I think, 46 folks compete, and we offered up some Android tablets. When this is all over and said and done, I'm going to go and figure out who the winners were. So if you're still here, meet me out there, and you can collect your Android tablets. How the winners are selected, we break them out into 3 groups: the beginners, the intermediate, and the advanced. And whoever's at the top of each of those tiers wins. And we have a random drawing. If you competed and finished one of the puzzles, you're eligible for a random drawing for one of the Android tablets. So for those of us who walked by and go, man, I don't think I have time to do that, man, you missed out. And the last random thing, I want to say thank you to the folks at Pi Ohio. They've been a fantastic conference. I really appreciate the support they've given to us as an organization, Booz Allen, and to all of you guys for coming. That's it.